Hello everyone, welcome back to Distributed Generation and Smart Grid lecture series. In the coming videos, we are going to discuss about the basic concept of load curve, different types of load, then peak load shaving, energy management, and demand response management, demand side management, etc. As we all know that there are different types of loads in our power system. These can be classified as a domestic load, commercial load, industrial load, municipal load, irrigation load, traction load, etc. So, domestic load, that is the load which can be considered in a domestic appliances as a fan, refrigerator, heaters, TV, pumps, etc. or a lighting load. These having a limited occurrence and the power factor is usually low, that is usually between zero point 0.1 to zero point 0.2. And commercial load, these are fans, refrigerator, air conditioners, etc. in our commercial buildings or lighting loads, and their occurrence is high, and these having seasonal variations. Then industrial loads means large induction motors and other industrial processes, heater, etc. And usually 25 kilowatt, which is considered as low. Medium is 100 kilowatt. High industrial load means greater than 500 kilowatt, etc. Then municipal load, street lighting, water supply, drainage, etc. Then irrigation load means which is supplied 12 hours during the night. Traction load, that is the trains, trolley, bus, electric railways, etc. This having the wide variations. So variable load on power system. The load on the power system varies from time to time due to the uncertain demands of consumer and is known as variable load on the system. But the load which is not varying, that is always present in the system, is known as base load. So there are two types of load in a power system, that is base load and a variable load. Then the another terminology related to the power system is a load profile. The load profile chart is known as the load curve. In electrical engineering, a load profile is a graph of variation in the electrical loads versus time. So a load profile will vary according to customer type. Typical example include residential, commercial, industrial, etc. So this one load curve, all of you know the load curve. The curve showing the variation of load on the power station with respect to time, which is known as load curve. Here one particular load curve is shown. You can see that time versus load in kilowatt for particular time hours. First 8 hours load is 200, then after that 700, then 150, etc. So maximum demand or peak load here it is 700, and average load, you can find out average load by taking its area divided by total time, that is the average load. And this maximum demand and average load you can calculate from a load curve. Then another important curve is load duration curve. So when the load element of the load curve are arranged in order of descending magnitude, The curve thus obtained is called load duration curve. That the same curve that we drawn here is you can draw like in a descending manner of the load in a particular time period. You can see one of such kind of load duration curve. Here you can see the high value of the load, that 50 kilowatt is the peak load. Then it is reduces to 35, then 30, 10, 5, etc. So it is arranged in a descending magnitude of the load, which is known as a load duration curve. Another example of a load curve and load duration curve is shown here. Here you can see that load curve, the first one is the load curve. You can see that for duration, first 4 hours duration 5 megawatt, then 4 to 8 it is 15, then 8 to 16 it is 20, then again reduced to 5 megawatt. So you can draw this is in a descending manner. That is the maximum value of the load is 20 megawatt. That is for a duration of 8 hours. So first you can draw 0 to 8 hours. That is it is only showing the load and its duration of existence. So 20 megawatt for 8 hours, then 15 megawatt for 4 hours, then you can see that 5 megawatt for 12 hour. So you are arranging it as a load, maximum load first, then its descending order and its duration. That is the load duration curve. So a load duration curve is obtained by arranging magnitude of corresponding load curve element in a descending order. But the area under the curve, both these curve are equal. Load curve and load duration curve are equal. And we can go through some of the important terms and factors relating with the power system. That is connected load. It is a sum of the continuous rating of all equipments connected to the supply system. Then maximum demand, it is the greatest demand of load of the power station during a given period. Demand factor, it is a ratio of maximum demand on the power station to its connected load. And all of you know that average load means the average load occurring on a power system in a given period. The average load you can calculate from that gives the area under the load curve divided by total time period. And load factor is nothing but is the ratio between the average load and it is a ratio between the maximum average load to the maximum demand during a period. Average load divided by maximum demand is the load factor. Then diversity factor, the ratio of sum of the individual maximum demand to the maximum demand on the power station. Another factor is coincidence factor. This factor is a reciprocal of diversity factor. Then contribution factor, it is a contribution of a particular load in a per unit of the individual demand to the group maximum demand. The another factor is plant capacity factor. So it is the ratio of actual energy produced to the maximum possible energy that could have been produced during a given period. That is plant capacity factor. Then plant use factor is the ratio of kWh or energy generated to the product of plant capacity and the number of hours for which the plant was operation. Then plant utilization factor is the ratio of maximum load to the rated capacity. So these are the some of the factors. Then connected load means it is the sum of the rating of all connected loads connected to the power plant. The demand factor and maximum demand we already discussed. So demand factor is maximum demand to the connected load is always less than 1. Here you can see one of the importance of load factor. Here you can see this figure is a load curve, that is the load versus time, and from this particular load curve you can find out the average load, that is the area under load curve divided by total number of hours, and load factor is average load by maximum demand. Then what is the importance of load factor in a power system? Here you can see that suppose there are two consumers, consumer A and consumer B, and their load curve is shown here, and you can find out load factor. Load factor is nothing but it is a ratio between average load to the maximum demand. And from this two load curve you can see that maximum demand of consumer A is 50 and the maximum demand of consumer B also 50. But the average demand of consumer A, that is the average demand of consumer A is 30. You can see from figure it is 30. But average demand of consumer B is 15 only, 15, 1 5. So what happened? Load factor. Load factor is for consumer A, load factor is average demand 30 divided by maximum demand 50. So it is 0.6. For consumer B, it is average demand is now for consumer B is 15 only. So 15 divided by 50, that is 0.3. So load factor of consumer A is 0.6, but load factor of consumer B is 0.3. That means even though the average demand of consumer B is less than that of consumer A, in order to meet the maximum demand of 50 megawatt, that is same for both these customers or consumers, we need to install the same capacity for consumer A and consumer B, because maximum demand is 50 megawatt. So we need to meet the maximum demand even though the average demand is very much lower for consumer B. So load factor low means that it is not recommendable, because it actually means its maximum demand is the same as that of a high load factor system, but average demand is low. So even though average demand is low, we need to meet the maximum demand also. So we need to install such a power system to meet that particular maximum demand. So both consumer use same maximum demand and accordingly require same investment in capacity. That is the problem. So maximum demand is same for both these consumers. So we need to invest. The investment cost for consumer A and consumer B both are equal, but each have different manner in using this capacity. That is indicated by load factor. If load factor is 1, means they are well utilizing the power system, but load factor is reducing means that their average demand is very low, but we installed such a system for meeting its peak load. So the investment is required for these two consumers are same, but they are using this particular system in different manner. So that is the importance of load factor. Then these are some of the equations. Unit generated per annum, you can calculate it as average load into hours in a year, or you can rewrite it as unit generated per annum is maximum demand into load factor into hours in a year is 8760, and you can calculate a monthly and yearly load curve is a ratio between number of generated units in a month to number of hours in that month. Or yearly average load is nothing but number of generated units in a year to number of hours in that year. And diversity factor. So as consumers, maximum demands are not simultaneous. The power station's maximum demand is less than that of some of the individual consumers' maximum demand. So we need to define a factor which is known as diversity factor, which is nothing but sum of individual maximum demands to the maximum demand on the power station. So here you can see in a picture where for a different load, 13.6 kilowatt, 12.2, 12.4, 11 kilowatt, etc. And its feeder maximum demand is denoted as 40. So diversity factor is sum of all this load, that is 49.2 divided by that power system maximum demand, that is 40, is 1.23. So diversity factor is always greater than 1. Then plant capacity factor is actual energy produced to the maximum energy that could have been produced. So plant capacity factor also you can written as average demand divided by plant capacity. And the reserve capacity is the plant capacity minus maximum demand. And another factor, plant use factor, is equal to station output divided by plant capacity into hours of use. And this one represent the power system base load and variable load that I already mentioned. Base load is the unvarying load that occurs almost all the day on the station. And peak load is the various peak demands over and above the base load. You can see in a yellow, you can see that base load. After that, and peak load is varying with respect to time. And significance of load factor we already discussed in that figure. These are some of the typical demand factors of residential, commercial, and general power services. Typical values of demand factors. And typical values of diversity factor for residential, commercial, and general power services is written, shown here. And you can go through some of the equation. You can write in different manner. Average load, daily average load. You can calculate daily average load. That is number of unit generated in a day divided by 24 hours. Then you can calculate monthly average load similar way. Then yearly average load. Then load factor is, we already discussed, it is a ratio between average load to the maximum demand. And the load factor also you can write it as average load by maximum demand or unit generated in particular hours to the maximum demand into time. Then diversity factor is a sum of the individual maximum demands to the maximum demand on the power station. Plant capacity factor, actual energy produced to the maximum energy that could have been produced, or it can be written as average demand to the plant capacity. Then annual plant capacity factor is annual kWh output divided by plant capacity into 8760. Then plant use factor is station output in kilowatt hour to the plant capacity into hours of use. Then load factor, unit generated per annum. As you know that load factor is average load by maximum demand. From that average load is maximum demand into load factor. So unit generated per annum is average load in kilowatt hour into hours in a year, or it can written as maximum demand into load factor into 8760. So these are the basic terminologies in the power system. You can go through some of the numerical examples for this in order to get a better understanding. Suppose the maximum demand on a power station is 100 megawatt, and if the annual load factor is 40%, you calculate the total energy generated in a year. So energy generated in a year, you can calculate from the equation maximum demand, that average load into hours in a year. That is the energy generated per year. So that is maximum demand into load factor into hours in a year. That is maximum demand is given 100 megawatt into load factor is 0.4, and into hours in a year means 24 into 365. That is 8760. That is equal to 3504 into 10 raised to 5 kilowatt hour. Then a generating station has a connected load of 43 megawatt and maximum demand of 20 megawatt. The unit generated being 61.5 into 10 raised to 6 per annum. Calculate the demand factor and the load factor. So demand factor is nothing but it is a ratio between maximum demand and connected load. Maximum demand divided by connected load. Maximum demand is given here 20. To the connected load is also given, that is 43. So you can calculate the demand factor as 20 divided by 43, that is 0.465. Then load factor is nothing but average demand by maximum demand. So average demand is unit generated per annum divided by hours in a year. Unit generated per annum is given 61.5 into 10 raised to 6 divided by 8760, that is hours in a year. So it is 7020 kilowatt. So average demand is 7020 kilowatt. So load factor is 7020 divided by maximum demand, that is 20 megawatt, that gives 0.351. And in this example, a 100 megawatt power station delivers 100 megawatt for 2 hours and 50 megawatt for 6 hours, and it is shut down for rest of each day. It is also shut down for maintenance for 45 days each year. Calculate its annual load factor. So this you can, first we need to find out energy supplied for each working day. That is, it is working for 200 megawatt for 2 hours and 50 megawatt for 6 hours. So you can calculate the energy supplied for each working day as 100 into 2 plus 50 into 6. Then you can see that the station operates on for the 45 days in each year it is shut down. So the remaining days only it is working. So station operates for 365 minus 45, 320 days in a year. So energy supplied per year you can calculate as 500 into 320. So annual load factor you can calculate as total energy supplied per annum divided by maximum demand into working hours into 100%. That is 20.8. This equation you can refer in the previous slides. Then another example is a generating station has a maximum demand of 25 megawatt a load factor of 60%, a plant capacity factor of 50%, and plant use factor also given as 72%. And we need to find out reserve capacity of the plant, daily energy produced, maximum energy that could have been produced daily if plant is plant while running as per schedule were fully loaded. So load factor, you need to find out the reserve capacity. Reserve capacity, you know that reserve capacity is nothing but is the difference between plant capacity and maximum demand. That is plant capacity minus maximum demand. And here maximum demand is given 25 megawatt, but we need to find out plant capacity. So plant capacity is simply average demand divided by plant capacity factor. Plant capacity factor is also given 50%. So we need to find out average demand. Average demand you can calculate from the equation of load factor. Load factor is given 60%. So load factor is average demand divided by maximum demand. So from that you can find out average demand. 0.6 equal to average demand by 20. So average demand is 15 megawatt. Plant capacity factor is nothing but it is average demand by plant capacity. So plant capacity is average, from that equation plant capacity is average demand by plant capacity factor, that is 15 divided by 0.5, 30 megawatt. So you got plant capacity and maximum demand. Now the reserve capacity is of plant is plant capacity minus maximum demand, that is 30 minus 25, 5 megawatt. Then daily energy produced is average demand into 24. So we will get 360 megawatt hour, and maximum energy that could have been produced from the equation of plant capacity, plant use factor, you can find out that actual energy produced in a day divided by plant use factor, that is 360 divided by 0.72, 500 megawatt hour per day. So then this particular example, a diesel station supplies the following loads to various consumers. That is, industrial consumer is 1500 kilowatt, commercial establishment is 750 kilowatt, domestic power 100 kilowatt, domestic light 450 kilowatt. So if the maximum demand on the station is 2500 kilowatt and the number of kilowatt hour generated per year is 45 into 10 raised to 5, determine the diversity factor and annual load factor. So diversity factor, you can individual load divided by maximum demand. So individual demand is given 1500 plus 750 plus 100 plus 450, that divided by 2500, you will get a diversity factor. Then you need to find out annual load factor. Load factor is nothing but average load by maximum demand. Average load demand you can calculate kilowatt hour generated per annum, that is given 45 into 10 raised to 5, that divided by hours in a year. So we will get 513.7 kilowatt. So load factor is the ratio between average load to maximum demand. You will get it as 20.5%. And another example, in this power station has a maximum demand of 15,000 kilowatt. The annual load factor is 50% and plant capacity factor is 40%. Determine the reserve capacity of the plant. And this you can calculate from the, it is similar to that of earlier problems. You can use the equations and you can calculate simply by the equations we already explained in our discussion.